Alright folks, hello and welcome to this video lesson. In this one we'll be continuing looking at the Pythagorean theorem and how we can use that to tell whether a triangle is acute, obtuse, or right. So last time we saw that the Pythagorean theorem said that a squared plus b squared equals c squared if and only if a, b, and c form a right triangle. Once again, I'm going to suggest that you copy down these examples into your notebooks so you have them for further reference. So this time, the only thing that's different is that we're given three possible side lengths of a triangle, here in number 1 and here in number 2, and our task is to analyze those lengths and use them to determine if the triangle is right, obtuse, or acute. So let's take the first lengths, and I'm going to teach you how to use the Pythagorean theorem to do just that. Given 7, 24, and 23, we know that 24 is our only candidate for the C. I'm going to rewrite the Pythagorean theorem with C on the left-hand side because our final conclusion is easiest to remember when it's based off of the C. And you'll see that in just a moment. So since 24 is the largest, it must be the hypotenuse if there is a hypotenuse. So we're going to put 24 squared on the left-hand side. Then on the right-hand side, we're going to put 7 squared and 23 squared. We'll add those together. Remember, we do not want to put just a flat equal sign. We want to have a question mark or some other box or something that indicates that we don't know that they're equal, because that's what we're testing. Okay, and then if you simplify this on your calculator on the left-hand side, you will get 576 equals question mark 49 plus 529. Feel free to use a calculator to help you out with any of this. And then we finally get the statement with 576 on the left-hand side, and the right-hand side simplifies to 578. At this point, I want you to put a correct symbol in between them that tells the truth of the relationship between those two numbers. So in this case, the left-hand side is greater than the right-hand side. I'm sorry, that's not right. I meant less than. So let's go to our eraser here, and we want to state that the left-hand side is less than the right-hand side. So if it's less than, if the C is less than the right-hand side, that's going to indicate that our triangle is acute. And you can think of that because an acute angle is less than 90 degrees. If it turned out to be greater than, we would declare obtuse, and as you saw in the last video, if it is equal to, that would be a right triangle. So let's see one more example here. This time we have 5, 12, and 14. 14 being our only candidate for C, since it is the largest. We'll set up 14 squared equals 5 squared plus 12 squared. Analyzing this relationship, we get that 196 is related to 25 plus 144. This leads to 196, and on the right-hand side we have 169, which means that the left-hand side is greater than the right-hand side. And as we just saw before, since this is a greater than mark, that would mean that a triangle is obtuse. Now, how does this relate to the picture of a right triangle, or any triangle? Briefly, does this make sense? And as you can see, it will, because if we suppose that a right triangle means they're just equal, and we're going to lengthen, let's say, this hypotenuse, make it a little bit longer. Well, if we wanted to keep A and B the same, but lengthen the hypotenuse, you can probably see that we would need to open up the legs to fit that new hypotenuse. And so if the C becomes greater than the A squared, B squared, that would create an obtuse angle on the inside. Likewise, if we were to shorten it, it would create an acute angle. Okay, but for your task in this lesson, you just need to have the skill of being able to identify whether three side lengths form an acute, obtuse, or right triangle using the Pythagorean equation. Thanks for watching this video lesson.